to write a fraction. If you remember the fraction remainder, the remainder number left over is your numerator, and the number we're dividing by 3 would be the denominator. So 101 divided by 3, our answer would be 33 2/3. Next question, we'll do the same process, but we'll use a polynomial which has variables. Next question, in parentheses, x cubed plus 8x squared minus 20x divided by x minus 2. From here we can set up the long division problem and divide, but instead of just numbers, we'll have variables to divide. Again, we can set up the long division symbol. The numerator, or top part of the fraction, we'll put inside x cubed plus 8x squared minus 20x. And the number or term we're dividing by, x minus 2, we'll put on the outside of the dividing symbol. To divide, x will take the first number, and x cubed also take the first term, and we'll divide x into x to the cubed, or you can think about x times what number would be x cubed. In this case, we'll have x squared, because x squared times x will be x cubed. So when we multiply x squared times x, we'll put x cubed underneath the x cubed, but we'll also distribute. X squared times a negative 2 would be negative 2x squared, and we'll put that underneath the x squared terms. So multiplying the top number by the term we're dividing by, we have x cubed minus 2x squared. From here, we'll subtract. It's a good idea to put parentheses around the term we're subtracting. X cubed minus x cubed would cancel out, and we'll have 8x squared minus a negative 2x squared. Since we're subtracting a negative, this will actually be adding 2x squared. 8x squared plus 2x squared would be 10x squared. Remembering these steps for long division, after we subtract, we can bring down the next term, which is negative 20x, and we'll repeat the process. Taking the first part of the term, x, we'll divide that into the first part of the term down here, which is 10x squared. Or you can also think what term times x will give us 10x squared. And that term will be 10x, because 10x times x is 10x squared. When doing long division, these first two terms always have to match up. Keep in mind, using the distributive property, we'll have 10x times a negative 2, which would be negative 20x. Again, you can put parentheses around the term that we're subtracting. 10x squared minus 10x squared would cancel, and negative 20 minus a negative 20. Subtracting the negative 20 will actually be adding, and negative 20x plus 20x would cancel. So we'll have 0, or a remainder of 0. And our answer above the dividing symbol will be x squared plus 10x. Next question, and last question for the section. In parentheses, x cubed minus 27 with a division symbol dividing by x minus 3. So again, dividing using variables, we can use long division. Again, we'll set up the long division symbol. Inside the dividing symbol, we'll have x cubed minus 27, but we'll change it a little bit. X cubed will go first. The next term after x cubed would be x squared. There's no x squareds inside this polynomial, but what we can do is add 0x squared as a placeholder. Similar to the first question we did with 101, you have to have that 0 for 101. For all polynomials, we'll have to have all of the exponents. We'll have x cubed plus 0x squared. After x squared, we'll have x. There is no x in the original question, so again we can add plus 0x. And after the x, we'll have the coefficient minus 27. When doing long division, it's very important to have all your placeholders and all of your exponents to get the correct answer. Dividing by x minus 3, we can put outside the dividing symbol. Dividing from here, we'll take the first part of the term x and divide it into x cubed. Or again, what number or what term times x would be x cubed. And that would be x squared. X squared times x would be x cubed. And again, using distributive property, x squared times a minus 3 would be negative 3x squared. Putting parentheses around this term and subtracting. The first term should always cancel out. X cubed minus x cubed will cancel. And 0x squared minus a negative 3x squared minus a negative will be adding 3x squared. So 0 plus 3 will be 3x squared. Dropping the next term down, 0x. Again, we'll divide x into 3x squared. Or what term times x would be 3x squared. And that term would be 3x. 3x times x is 3x squared. And 3x times a negative 3 would be minus 9x. Again, the first term should always cancel. 3x squared minus 3x squared. And 0x minus a minus 9x will be adding 9x. So 0 plus 9x will be 9x. Bringing the last term down, minus 27. X into 9x, or again, what term times x would be 9x? And that term would be a positive 9. 9 times x would be 9x, and 9 times a negative 3 would be negative 27. Subtracting, if these last terms match up, 9 minus 9 and negative 20 minus a negative 27, or adding 27, the 0 means no remainder, and our answer will be x squared plus 3x plus 9. Title of the first section today is Review Long Division. In this section, we'll review how to use long division for polynomials. First question, 3c to the 5th plus 5c to the 4th plus c plus 5 all over c plus 2. Again, we can use long division to divide polynomials to solve the question. First part, we can draw the long division symbol. The numerator, or top polynomial, would go inside the division symbol. 3c to the 5th plus 5c to the 4th. After c to the 4th, though, instead of plus c, we'll need c to the 3rd. Since there's no c to the 3rd, we can put plus 0.3 cubed. After c cubed, there's no c squared. And after c squared, we can put plus c from the problem, and also plus 5. Outside the division symbol, we're dividing by c plus 2. Dividing from here, c into 3c to the 5th, or what term times c is 3c to the 5th? That would be 3 c to the fourth. Multiplying 3c to the fourth times c, that would be 3c to the fifth, and 3c to the fourth times 2 would be a positive 6c to the fourth. Putting the new expression in parentheses and subtracting, the first terms again should always match up. If they don't, you have to go back and double check your multiplication and your terms. The second terms we can subtract. 5c to the fourth minus 6c to the fourth would be negative 1c to the fourth. Dropping down the next term, which would be 0c cubed. C into negative 1c to the fourth would be negative c to the third. Negative c to the third times c would be negative c to the fourth. And negative c cubed times 2 would be negative 2c cubed. Negative 1c to the fourth minus a negative c to the fourth. Minus a negative will actually be adding, so the first terms will cancel. And 0c cubed minus a negative 2c cubed minus a negative will actually be adding, so we'll have 2c cubed. Bringing down the next term, 0c squared. C dividing into 2c cubed would be 2c squared. Multiplying 2c squared times c, that'll match up with 2c cubed. And 2c squared times 2 would be plus 4c squared. Subtracting, the first terms will cancel, and 0c squared minus 4c squared would be a negative 4c squared. I'll write the negative 4c squared up top, and we'll bring down the next term plus c. Dividing c into negative 4c squared, that'll be negative 4c. Negative 4c times c will be negative 4c squared. And again, the first terms always have to match up. And negative 4c times 2 would be negative 8c. Negative 4 minus a negative 4, or adding 4, would cancel. And 1c minus a negative 8c, minus a negative will be adding 8. So 1c plus 8c would be 9c. Bringing down the last number, which would be a positive 5. Now we have c divided into 9c, which would be plus 9. 9 times c would be 9c. And 9 times 2 will be 18. This time the last term doesn't cancel, so we'll have a remainder. 9 c's will cancel, but 5 minus 18 would be a negative 13. The remainder, negative 13. What we can do is write our final answer using a fraction. The minus 13 will be the numerator. And the denominator, if you remember for fractions, for long division, whatever we're dividing by, c plus 2 will be the denominator of our remainder fraction. So our final answer is everything on top of the division symbol. 3c to the fourth minus c cubed plus 2c squared minus 4c plus 9 minus the fraction 13 over c plus 2. Title of the last section today is Synthetic Division. In this section, we'll divide polynomials with variables, but instead of long division, we'll use synthetic division. One definition or rule for synthetic division is divisor must be, in parentheses, x minus r. What this means is for synthetic division, the divisor or polynomial or binomial that we're dividing by must be of the form x minus r. X cannot have a coefficient or can only have a coefficient of 1, and also x cannot have an exponent or it only has to have an exponent of 1. Minus r means it could be minus any number. It could also be minus a negative number, which would be plus r. But it has to be x and then a single number after x. Taking a look at the first question. In parentheses, 5x cubed minus 13x squared plus 10x minus 8, and a division symbol dividing by, in parentheses, x minus 2. Looking at this problem, the divisor or phrase that we're dividing by is of the form x minus r, or we have x and then a single number after that, which means we can use synthetic division. To start synthetic division, we'll draw a spot, kind of like a box in the top left-hand corner. Inside this box, we'll put a single number. This number, looking back at the divisor, x minus 2, we'll take the opposite of negative 2, which will be positive 2 or just 2, and we'll put that number inside the box in the top left. Next to the box, along the top, we'll write the coefficients of the original term that we're dividing. We'll take off all the variables and just use the coefficients. So the first coefficient would be 5, the second coefficient, negative 13, the next coefficient, 10, and the last coefficient, negative 8. From here, we'll skip a spot to fill in some numbers in a little bit, but we'll draw a line underneath that. To use synthetic division, we'll take the first coefficient, 5, and we'll drop that straight down underneath the line that we drew. The second step, we'll take the number inside the box, which is 2, and we'll multiply by the number that we have on the bottom. So in this case, 2 times 5 would be 10, and we'll take this 10 and write it underneath the next coefficient. So again, we'll drop the first number down without changing it, and then we'll multiply, put the product underneath the next coefficient. The rest of the problem will continue the same, but with these two coefficients, we'll end up adding these two coefficients together. Negative 13 plus 10 will be negative 3. After we add the two numbers together, again, we'll multiply this number times 2, and the product we'll put underneath the next coefficient. Each time we have two numbers, we'll add those two numbers together. 10 plus negative 6 would be 4. Multiplying again, 4 times 2 would be 8. And negative 8 plus 8 would be 0. The 0 at the end represents that there's no remainder for this question. Our final answer, these are the coefficients, 5, negative 3, and 4. To put the variables back in, looking back at the original question, we had x cubed, but since we're dividing by x, we're going to reduce the exponent by 1. So instead of x cubed, the 5 will become 5x squared. And likewise, the minus 3 or negative 3 will decrease the exponent by 1. So we'll have 5x squared minus 3x. And after the x, we'll have just the single number, which would be plus 4. So our final answer to the division question would be 5x squared minus 3x plus 4. Second question, and last question for the section. In parentheses, y to the 5th plus 32 times a second parentheses, y plus 2 to the negative first power. Again, it looks like a multiplication question, but the negative exponent again, we can rewrite in the denominator as a positive exponent, positive 1, or we can leave it off to have it dividing by y plus 2. Looking at this question, the divisor is in the form x minus r. Instead of x, you can have a different variable. And again, instead of subtracting the number, it's okay to add a number. But if there's ever a coefficient in front of the variable, if you ever have an exponent, then we cannot use synthetic division. To set the question up again, we can first draw a box in the top left-hand corner. If we have y plus 2, we'll do the opposite of plus 2, so we'll have negative 2. And then the coefficients for the original polynomial we're dividing will go across the top. Y to the 5th has a coefficient of 1. Keep in mind, just like long division, we need placeholders for exponents that we're missing. There is no y to the 4th, so we can put a 0 for y to the 4th. We can also put 0 for y cubed, 0 for y squared, 0 for y, and plus 32 at the end. So we'll have y to the 5th, y to the 4th, y cubed, y squared, y, and the constant coefficient. From here we can draw the line on the bottom. And if you want to, you can add a plus sign, so you remember to add the numbers as the problem continues. The first number always comes straight down, and we'll always multiply by negative 2 for this question. Negative 2 times 1 would be negative 2. Adding 0 plus a negative 2 would be negative 2. Multiplying negative 2 times negative 2 would be positive 4. 0 plus 4 would be 4. Negative 2 times 4 would be negative 8. 0 plus a negative 8 is negative 8. Negative 2 times negative 8, 16. 0 plus 16 would be 16. And negative 2 times 16 would be negative 32. Adding 32 plus a negative 32 would be 0. And again, a 0 for the last number represents no remainder. If you did have a remainder, you can make a fraction for your final answer. These again are the coefficients. Putting the variables back in, we started with y to the 5th. Since we're dividing by y, we'll take off one exponent. So the 1 would be 1y to the 4th, or just y to the 4th, minus 2, y cubed. Each time will decrease by 1 for the exponent, plus 4y squared, minus 8y, and plus 16. So our final answer, y to the 4th minus 2y cubed plus 4y squared minus 8y plus 16 with no remainder. If we did have a remainder, we could have a fraction on the end. Degree and leading coefficient of a polynomial. The definition for a polynomial is you cannot divide by a variable or have a square root of a variable. If you divide by a variable or have a square root of a variable, then it is not a polynomial. Degree is the highest exponent if you have a single variable, or exponent total of a term if you have multiple variables, which is the sum of the exponents. And the leading coefficient is the coefficient or number in front of the degree. Title of the first section is Find the Degree and Leading Coefficient. In this section, we'll find the degree of a polynomial and also the leading coefficient of a polynomial. First question, negative 3x squared plus 5x minus 7. Find the degree. When you have a single variable, the degree will be the highest exponent. Looking at the exponents, the highest exponent is 2, so the degree would be 2. For the leading coefficient, leading coefficient is the number in front, or coefficient for the degree. Since our degree is 2, the coefficient of that term is negative 3, so the leading coefficient would be negative 3. Next problem is 5a plus 2 plus a squared. The degree, which again is the highest exponent, would be 2. And the leading coefficient, leading coefficients, the coefficient in front of the highest exponent, which in this case would be 1. Next problem, square root of y plus y cubed. In this problem, the highest exponent would be 3, but looking at the other term, we have square root of y, or square root of a variable. And looking back at the definitions, if you have a square root of a variable, this would not be a polynomial. If you have a square root of a variable, or again if you divide by a variable, it's not a polynomial, so there's no degree and no leading coefficient. And last question for the section, 2x squared y plus square root of 2 x squared y cubed minus 4 x to the fourth. In this problem, we have a square root of a number, square root 2, which is fine, so this is still a polynomial. The degree, again, is the highest exponent, or when you have multiple terms or multiple variables, it's the sum of the exponent term. This first term would have a exponent of 1 for the y, so the total would be 3. The second term, the sum or total would be 5. And the last term, the total would be 4. So our degree, the middle term, adding the x and y exponents, the degree would be 5. And the leading coefficient, leading coefficient, again, the number in front of the term with the degree. X squared y cubed was the degree 5. The coefficient, or number in front, is square root of 2. Title of the next section is Evaluating Functions. In this section, we'll evaluate functions by plugging in numbers or variables to each function. First question, if p of x equals 3x squared minus 2x plus 5, and r of x equals x cubed plus x plus 1, find following numbers. First part, or first question, P of 2